Okay, can you hear me? Great. Yeah. Um, if you want, the Zoom audio is better. It's more interactive and also it's less laggy. Um, I'm going to enable both audio just in case somebody missed the Zoom audio, so the recording will have the audio. And let me see. Great, thank you. Yeah, I just started the meeting. I see people are coming in. Okay, Manny, you're in the meeting already. Okay. Um, Anybody else? Okay. Okay. So can you hear me in the Zoom? Anybody give me some feedback, please? Okay, great. Thank you. Okay, let's give the rest of the class a few more minutes to participate because I'm still missing a few in the Zoom. Let me see. Oh yeah, that's fine. Just log in so I can see that he's in. Um, yeah, thank you. So I'm seeing that we have Manny, Aaron, Corbin, Van, Jesse. Okay, let's see. William. William, are you on YouTube? I cannot see you. Okay, please just join YouTube so I can have a recording of your attendance. Rawa, Abdullah Gandhi, Mahama Akali, Douglas, Ibrahim. Okay, Mahama Akali, yes, thank you. Abdullah Gandhi, Rawa. Okay. Okay, Rawa, yes. All right. Okay. Oh, yes, Douglas, thank you. Ibrahim Abdullah Agamdi. Alright, let's see. Yes, Aaron, I get you. Yes, thank you. All right, so let's look at the lecture notes today. So we are going to go over D7, which is the last assignment for this class. Okay, so if you go to ULearn, everything is already posted. So this is the handout. This is the command 1, 2, 3, 4. So look at it. Command 1, you implement that in D6. Command 2, implement in D6. 3, same thing. So the new command is D4. And instead of using sequence number 1, we're going to use sequence number 2. So let's click on these. Let's look at the sequencing. Okay. All right. So let's see what's going on with D7. For D7, we are going to implement the circuits to interface with both x-axis and y-axis. So same orientation of the board. VGA connector facing left, and then left is minus x, right is plus x, up is plus y, down is minus y. Okay? That's the orientation. All right, thank you, Christian. I got you. Yes, I know you're busy with something else, so just listen to the lecture. All right. Okay. All right. Well, let me get the attendance done. Give me 2 minutes. Yes, I'm pretty sure everyone is in. All right. Yeah, you go to Zoom and then also check into the YouTube to make sure that you can get the video on your laptop, on your desktop, on your tablet. Okay, so let's continue. All right. So I'm missing Maham Abdullah Agamdi. Are you here? Yes, bravo, I got you. Thank you. Yeah. So you see my screen? All right, so if you look at this orientation, this is exactly the same orientation we use for D6. Okay. Um, the challenge for this assignment is that you need to implement one more command. Okay. So let's look at the command sequence, which is this. So last class we talked about you need to implement a command to power on. Yes, Mohammed. Any question? No. So the command one is to power on the device, configure the communication. Something is not right here. This is not the right sequence. No, it should be x-axis, y-axis. I think it's a typo. It should be x-axis and y-axis. Okay, not y and y. It should be x-axis and y-axis. I'll fix this. Okay. All right. So the sequence is get the x-axis, update the 77 display. Get the y-axis, update the 77 display. Okay. So the new command is this command: how to read x and sorry, how to read the y-axis. If you look at this command, pay attention to this command. This is the y-axis. If you look at the x-axis, they are almost identical. So you look at these bits patterns is 1111, four ones, 0010. Okay, four ones, 0010. If you look at the y-axis, see it is 1111, four ones, 0100. So that's the difference between these two. So that it is 0100 for y and 0010 for x. Okay, so that means if we finish our x-axis, you can easily modify the design to get the y-axis done because they're almost the same. The only difference is the middle 4 bits that you need to take care. Okay. All right. Same thing. You get 8 bits coming in to the board from your circuit, and then he's gonna spit out 16 bits from 7 to 0 and then 15 to 8. Okay. So the blue arrows means the capture point. This means where you can capture the data. Okay. Now on the falling edge of the clock, the S clock, the data will come out from the sensor or the 2D joystick, and you cannot capture it right away. You want to go to the next state, then you capture it. At the same time, you can change the value of your output. Okay, so similar to D6, you cannot change any output at the same time. So if you look at it, when CS is changing from high to low or low to high, S clock is not changing. S clock is not changing. SDI is not changing. And SDI is not changing. Okay. So you have to fulfill this requirement. Otherwise, you violate the timing requirement for the device. And then it won't give you something reliable. All right. So this is the new command. This is a new sequence. X-axis, Y-axis, X-axis, Y-axis. And then you update the 77 display. Okay. So now we need to look at if you have two readings. In theory, 16-bit inch, you need 4 hexadecimal display for each reading. That means you need 8 displays. But we don't have 8, we only have 6. So how do we deal with this? Okay. From these 6 assignments, okay, when you work on it, you realize that these 6 limits or the reading limits are FF00 to 00FF. Look at your reading. It doesn't matter how you do it. You're not going to go beyond 00FF. You're not going to go beyond FF00. Okay. The reason is when you start tilting the board, the sensor is going to pick up the angles. And then there's a limit on the angles. Now we know that for angles, it's plus minus 180 degrees. You cannot have more than that. Okay? So when you use this sensor to measure the angle, automatically you know that there's an upper limit, there's a lower limit. The sensor is way capable of measuring um, beyond this limit, but because of the physical limit, you're not going to go beyond 00FF or FF00. So that means these three digits are relevant to our measurement. These three digits are relevant to our measurement. The first digit is always the same as the second digit. Okay, so what I'm trying to say is if you measure FFFF, four Fs, the first two digits are the same. If you measure 0000, the first two digits are the same because based on D6, this is your limit. You're bounded within this limit. You're bounded within this range. So you cannot go over that. So that means effectively that 16 bits you're reading, you have to read 16 bits. It's effectively 12 bits because the first four bits or the first four MSBs are not that useful. So for this assignment, we only care bit. Okay, we don't use the four MSBs, so we only use bit 11, 10, 9, 2, 1, 0. Okay, but you still need to read 16 bits. If you don't read the 16 bits, you don't have the full measurement. Okay, but when you read the 16 bits, you don't need to put the most significant bits to the display. You can keep them internal to the circuits. You still need to capture it. Okay, because you look at the command structure. This is for the y-axis. When you read the bits, you need to read 7, 6, 5, 4, 3, 2, 1, 0. Then you read 15, 14, 13, 12, and then 11, 10, 9, 8. You cannot skip the middle four. You still capture it, but you're not using them. Understand? So this is going to be the bits we're going to use. If that's the case, we have 12 bits for X measurement, 12 bits for Y measurement. Total is going to be 24 bits. And 24 bits, you need 6 hex digits. Okay? So that means hex 0, 1, 2 is for X axis. Hex 4, 5, 6. I'm sorry. 3, 4, 5 is for Y axis. Okay. All right. So let's look at the board. So this is, remember, this is your 5, 4, 3, 2, 1, 0 because everything is upside down. Okay, everything is upside down. So that means hex 0 is MSB, hex 2 is LSB. Okay, so let's use uppercase and now lowercase. Okay. Hex 3 is MSB, hex 5 is LSB. Remember, all hex are upside down. That means you need to use the values which I gave you in previous week to display the zeros and to the F's. So you go to ULearn, you look at the lecture from so this is what we're talking about. This is the upside down version of displaying 0 through F on a decimal display. Okay, if you use your D2, it's not going to work. Everything is upside down. You have to use these values. So far, any questions? Okay. So far, so good. Anybody else? Okay. No questions. That's great. So these are the basic setup for the board and for the display. Okay. Now, when you work on these assignments, what you find out is the x-axis and the y-axis they're completely independent, meaning that when you tilt left, the y-axis won't be affected at all. When you tilt right, same thing. If you tilt forward or backward, the x-axis won't be affected at all. Okay, now you want this because you don't want x-axis changing and then suddenly it affects the y-axis. Okay, and this is the typical setup for these kind of sensors. They have to guarantee x-axis is independent from y-axis. Okay, so there's no coupling between these axes. Otherwise, you go crazy. The reading is all over the place. Okay, all right. So another interesting question, which is not related to this class, is here is the z-axis. It's worth thinking. Okay, you don't do. There's no assignment for this, but you think about this. You tilt left, you tilt right, you tilt forward, you tilt backward. Where's the z-axis? Because every time we talk about 3D, it's going to be x, y, z all the time. So where's the z-axis? So physically, there has to be something that can happen to trigger the z-axis change. Okay? Again, there's no assignment, just a question that you think about it at all. Okay? If you want, you can read a data sheet for the device. Then you can know the z-axis, how to change the z-axis. Right. So next, we're going to talk about the command sequence. So now we know you need to do command 1, 2, 3. Now a drop or a rise is going to be changed in the y-axis. Think about this. You're measuring angles. Changing horizontal, changing vertically up or down doesn't change the angle. So it will not change the y-axis or the x-axis. Okay? As long as you guarantee when you rise or drop, it's 90 degrees. Okay, then there shouldn't be any change in the x and y. Okay. Again, go to read the data sheets if you are interested in this to figure out where's the x the z axis. Okay, it is not obvious. Okay. Let's come back to this. The sequence 1, 2, 3, 4. So the command itself is not difficult. The difficult part is how many states you need. Okay, now this is not a travel light controller where you know why. For travel light controller, you need so many states. Very likely, it's less than 10 or less than 20. But for this complicated state machine, we're not talking about 10 states. Okay, so that will be the focus, the lecture for now. Okay, so we know these are the commands we need to implement. Up, command 1, 2, you do it once. Okay, and command 2, you run once because you need to power on the device. You do it once. You need to configure the communication. You do it once. And then 3 is to read the x-axis, and then you need to run it many times. Similarly, for command 4, you need to run it many times because you need to read the y-axis continuously. In between 3 and 4, you should update the 7.7 display. Okay? Okay. So this is x-axis only, and this is y-axis. Or you may ask, how come we don't do all the updates at once? You can do that. It's not necessary. The reason is when you do these updates, you're doing it in milliseconds. You cannot even tell with your eyes, oh, you just updated x-axis or you just updated y-axis. Okay, so to make the problem, make the solution more uniform, you read, you update, you read, you update. Okay, right. So let's look at command one. Let's figure out how many states you need. So going back to the waveform. Waveforms, we have command number one. So this is command number one. All right. So you start counting. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 arrows. 1, 2, 3, 4, 5, 6, 16 arrows. That means there are 16 capture points. Okay. There's 16 capture points. 16 captures. Even though you don't do anything with the values, you still need to capture them. Okay. 16 capture points means 16th S clock equal to 1. 16 S clock equal to 0. Okay? So S clock equal to 1, S clock equal to 0. So to make the S clock equal to 1, you need one state. If you want to make the S clock equal to 0, you need one more state. Okay, then you capture. Okay? So while you're capturing, SDI is not changing. S clock is not changing. So from 1, 0, capture, there are 3 states you need. Okay? So if you do the math, it's equal to 16 for the S clock equal to 1 plus 16 for the S clock equal to 0 plus 16 capture. So this is 48 states. Okay? But look at it carefully. There are more here at the beginning and there are more here at the end. Alright? So the beginning is CS must start with a 1, S clock must start with a 1, and the SDI must start with a 0. So to accomplish this, you need CS equal to 1, S clock equal to 1, SDI equal to 0. This is one state. The next state, CS equal to 0, S clock is not changing, SDI is not changing. You need two states. Okay. Then the third state is you need CS equal to 0, S clock equal to 0, and SDI equal to 0. So that means you need to plus 3 states here. Similarly, if you go to the end of this command, when you finish everything, you want to finish with SDI equal to 0, then S clock equal to 1, then CS equal to 1. So you need 3 states. So if you do the math, yes, D6 was due before class. So this is equal to 48 plus 6, 54 states. So you do have a state machine that will have 54 states just to power on the device. Okay? Alright. So if I move on to the next commands, any question about the process to determine how many states you need? Any question about how many states we need for command number 1? No question is good. Alright. So let's move on to command number 2. Okay. So for command number 2, you look at the link. Command number 2, similar configuration. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 arrows. 1, 2, 3, 4, 5, 6. 6 arrows. 16 arrows. Okay. You have a similar setup in the beginning. You have a similar setup in the end. Okay. So for command 2, you have 16 captures. Again, you need to capture, but you don't do anything with the values. 16 as clock equal to 1. 16 as clock equal to 0. Okay. So how many states we need? Okay. I just gotta remind you saying that the Zoom meeting will terminate in a couple minutes because of the time limit for the free version. Okay, if it ends, what I'm going to do is I'm going to post a new link on Learn for the Zoom, and then you can just call into the different link. Okay. All right. So if you look at this, it's ended up 56 states. Sorry, 54 states. When you run command 1, command 2, there's no need to update the display because there's nothing to update. You don't even have a reading yet. By default, all the readings should be blank. You just power up the device, they'll all be blank or all zeros, meaning that there's no reading. Zero means nothing is moving. There's no angle anywhere. Okay? All right. All right, let's continue. Command 3. Command 3 is more complicated because you get a lot more clocks. So look at this diagram. This is the diagram to read x-axis. If you start counting the arrows, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 20. 1, 2, 3, 4. 4. So 24. So how many states you need? You have 24 captures. 24 as clock equal to 1. 24 as clock equal to 0. So do the math. The beginning is 3. The end is 3. You're going to have command 3 is equal to states 24 plus 24 plus 24 plus 3 plus 3. So do the math. What do we have? This is 70, 48, 72 plus 6, 78 states. So we have 54, 54 plus 78. Okay. Command 4. Let's look at the diagram for command 4. Command 4 is command 4, which is reading the y-axis. Count the arrows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 arrows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 20 arrows. 1, 2, 3, 4. 4 arrows. Plus 3 in the beginning, 3 at the end. So this is exactly the same setup. Command 5. Sorry, I don't need command 5. Command 4 states is equal to 24 plus 24 plus 24 plus 3 plus 3. Okay. So after command 3, you have update 7 segment display x axis only. So how many states is that? one state. You need only one state to take care of the update. And then same thing for the y-axis, you need one state. Right. So now we have created a sequence for the number of states for each commit. So let's do the total number of states. Okay. So command number 1, 54. Command 2, 54. Command 3, 78. Update display, 1. Command 4, 78 plus 1 for the updates. So if you do the math, you can do 54 plus 54 plus 70, 54 plus 54 plus 78 plus 1 plus 78 plus 1 is equal to 266 states. And this is minimum number of states you need. Okay? You can have more states, but this is the minimum you need. On top of that, the x value is equal to 20 nanoseconds, and the y value is equal to 200 microseconds. Okay? All right. So if you look at this, now you need to design a state machine that's at 266 states minimum. Okay? All right. So the question is, can you do this? Yes, you can, because you're using VHDL. You're not writing any drawing any schematics or block diagram. You're writing a piece of code. Okay? The code is much better and much more efficient in this case, because you don't need to deal with the interactions between all these flip-flops. What you need to know is I need 266 states. Okay? All right. For 266 states, how many bits do you need? Because when we put down the states, you need to put down how many bits. Okay, so let's do the math. If you have 1 bit, you can have 2 states, 0 or 1. 2 bits, 0, 0, 0, 1, 1, 0, 1, 1, 4 states. 3 bits, 8 states. 4 bits, 16. 5 bits, 32. 6 bits, 64. 7 bit, 128. 8 bits, 256. 9 bits, 512. So you know, if you have only 8 bits, it's not going to work because you need 256. Sorry, you need 266. But 8 bits only gives you 256. 9 bits will give you 512. So 9 bit is the solution. So when you define the constants for the states, it's 9 bit value. Okay? 9 bit value for each state. The rest is mechanical because you need to type it up. From state 1, you go to state 2, to 2 to 3, 3 to 4, 4 to 5, 5 to 6, and continue. And when you finish number 4, you finish here, you need to loop after this state. Okay? And where do you loop? You loop back to command 3. And then the whole thing will be command 1, command 2, 3, update, 4, update, and then go back to 3, updates, 4, updates. So you keep in this loop. And now give you the continuous reading. Okay? And when you read, each state change every 200 microsecond minimum. Now you can make it longer, you can make it 400, you can make it 500. It just slows down the process. Each time you change states, you can only change one state at a time. That's why the X and Y values are 20 nanoseconds and 200 microseconds respectively. Okay, all right. So if you do the math, we know 266 states is the minimum we need. So you do the timing calculation. 266 states times 200 microseconds per state, okay, is going to be equal to, let's do the math, 266 times 200 divided by 1 million. It's about 53.2 53.2 milliseconds. Okay. All right. I think the Zoom meeting just I think the Zoom meeting just finished. So what I'm going to do is I'm going to create a new one so that then we can continue. So give me a couple minutes. Okay. All right. All right. Give me a couple minutes. Let me set up a new meeting. Okay. I just updated ULearn link with a new meeting number and password, so you can join that one. Okay. It has started already. Okay, Manny, can you hear me? Okay, can anybody hear me besides Manny? Okay, great. Thank you. Anybody else coming in? Okay, thank you. Okay, good. So let's continue. So what we did just now, we calculate the timing for all states. So if you want to run all the commands, all the updates at once, this is time it takes to finish it, 53.2 milliseconds. But we know that command 1, command 2 only run once. So it is necessary to calculate the timing for 3 and 4. Okay. So for 3, it's 78 plus update the display plus 78 plus 1. Right. So if you do the math, this is 158 states. Okay. So we're running in a loop. It's 158 states. So for loop is 158 times 200 microseconds. So do the math. 158 times 200 divided by 1 million. It will give you 31.6 milliseconds. So this means you get about 33 readings per second. That's what I said before. It's between 30 and 40. Okay, so that would be fast enough. Imagine when you play your video games, the controller doesn't respond in split seconds because when you move your controller, there's a certain rate it responds. Okay, I don't know about the rate. I guess it's not going to be 100 and 200s. Probably it's between 20 to 60. I think that's the most. Because there's no need to do that. Okay. I'm not talking about the mouse. I'm talking about the joypad that you're using for your video console. Okay. All right. So if you look at these calculations, this is good calculation because it shows you get 33 readings per second, which is significantly fast. Think about this. Your TV is about 40 frames per second, at most 60. Right now, your joystick will give you half of the speed. Okay. I mean, if you look at how fast we can move, the bandwidth for physical movement, hands and legs, and any body part, it's about maybe 10 hertz at most. That's the fastest you can do. Okay, that means if you press a key, press release, the most you can do is about 10 times per second. You cannot beat that number. Okay, and what we're doing is 3 times that, which is significantly higher. Okay. All right, so let's look at the template for this assignment. The seventh template. Okay, this is the VHDL template. This is a template which I'm going to post on your after this. So it is exactly the same inputs. For the reset, we're using key 0. For the clock, we're using clock 1. Then we have 3 outputs: CS, S clock, SDI. 1 input, SDI. And 6 hexadecimal display. Hex 543210. Alright? And we know that when you define constants, there are 266 states you need to define. Okay? Um, it's long. You need to sit down and do the work, but there's nothing around it. You have to do it. Okay. So I spent about 1 day typing everything up, and then spent about half day to finish debugging. Of course, when you start typing in everything, nothing will work at the first attempt. It's okay, but you need to know, right? So it doesn't work. What do? I need to know the states. The states are there. I'm making transitions. I can see the reading. Okay, now because you finished D6 already, so that means you have something that's working for the x-axis. So now you need to update to include the y-axis. So it's not like you start from scratch. You have already something that, and that's significant because from command 1, 2, and 3, we're talking about more than 60% of the work. In command 4, just additional 30 to 40% of the work. Okay? So why is this due? It's last day of class. Okay, I'm gonna tell you the exact day. Don't worry. Okay, so 2 p.m. before class starts. Okay, last day of class is Thursday, May. I think it's 14, May 14. Okay, so you get today. You can start working on it. Thursday, there's nothing due. Next Tuesday, there's nothing due, and next Thursday, this is the last assignment. Again, it's not difficult. It's just law, and most of the time, in engineering, it's law. The task is not very difficult, but it is time consuming. You need to sit down and type every single thing out. Nobody can type this for you. You want to type it yourself. Okay? And then if something doesn't work, you need to do the debugging. And there's no way around it. There's no way to automate this process. You have to sit down and type. Understand? Any question about the due date? Yeah, again, it is long. And this is it. There's nothing you can do about this. It's the time you spent on typing. Okay? I've given you all the information you need. I've given you the handouts, the command 4, 3. This is the sequence. I'm going to fix the typo. It's supposed to be x-axis, then y-axis, not y and y. Command 2 and command 1. So one, two, three, four commands. You need to implement. Okay. Any questions? Okay. No questions. Good. But you need to do it. I know, I know it is long. I spend one day just sit down in front of the computer, start typing in these numbers. They're not difficult. You think about this. It's not like, oh, you can write this program to do this sophisticated. No, there's no DSP, there's no math. Everything is done, given to you. It's digital already. Your job is to output the right number, capture the at the right time, and then put it on the 7/7 display. That's it. You don't even do. There's no math involved. You just sit down and do it. Okay. The only thing that you need to be careful is if you do not do this correctly, then what will happen is the speed will be changed, and then you may either reading it too fast or reading it too slow. Okay. Now, 200 microsecond is a very good number. If you make this 300, then what happens is you just slow down everything. If you make it too slow, eventually you can see the reading changing. Okay, you don't want to run this at 1 hertz. The reason is when they take the measurements, they're using an analog to digital converter. If you make the converter running too slow, you lose the precision. Okay, you know that from DSP, you know that. Okay, when you convert an analog value to digital values, you're gonna obey certain rules. You cannot do it too fast because you don't get precision. But if you do it too slow, you also don't get precision. It has to be just right. Okay, and then this number that I give you is just right. There's a range of numbers you can use. You can use 200, you can use 300, you can use 250. It doesn't make any difference. As long as you fall into that range, you're good. The moment you fall out from that range, all these numbers are garbage coming back. Okay, yeah. See, yeah. Hopefully it works. I spend one day typing, and then I spend half day debugging. When I say half day, I don't mean 8 hours. It's probably 2 or 3 hours, because I know that my X always work. So now I put in a Y, then I should see the Y changing as well. But the Y should not affect the X. X should not affect the Y. Okay, that's it. If you see that both changing independently, then you're done. Take video, upload. Yeah, most of the engineering work, especially in digital, is long. It's lengthy. It's long. It's time consuming, but it's not difficult. Okay. On the other hand, if you do C programming, it's more difficult because everything is it's inside a program. If you type in the wrong function or wrong variable, you may be there debugging for days. Oh, I typed in the wrong variable. That's possible, but this is very obvious. When it works, it doesn't work, and then you know exactly how to control the output sequence. Okay? When you work on this assignment, these diagrams are very useful. The data sheet also has diagrams, but they're not as clear as this. First of all, they're black and white, and then this is color. And then here it marks you where you're supposed to capture the data, where you can change the data. Okay, so that's important because once you know where you can capture, where you can change data, everything else again is mechanical. You can type this out one day, type it out, or 2 days, type out everything, and then start doing debugging the third day. By the fourth day, you should be done. Okay. Okay. Yeah. Again, this is the last assignment. There's nothing else to do. The only thing left is D7 and the final. Okay. For the yeah, you will be because on the final exam, you're not going to design a state machine that has 200 states. It's crazy. You cannot do it in an hour. But when you're given 1.5 weeks, you can finish it. Okay. Yes. And then some of you who are graduating, this is probably the last assignment. Yeah. So almost this is over. May 8th, I think, is the last day for the lockdown, and wait for the governor to see what she's going to say. Maybe she'll say, "Let's do another month." Okay, then we'll just stay home. Or, or she'll say, "Just get out and go out, enjoy your life." It's also possible. Nobody knows. Okay. It's okay when everything comes down. We'll call you, and then you fly back and do the ceremony. Right now, I don't even know they have flights going back to Saudi. Do they? Oh, okay, okay. But it's limited, right? It's not like every other day or every day you have a flight. It's the only schedule. Okay, that's fine. It's okay. Yeah. Now the weather is better. You should enjoy your life. But again, follow the rules. If they ask you to wear mask, wear mask. Okay. I don't know if any of you is driving outside. I I do grocery shopping every week. I realize lately there are a lot more cars on the street. A lot more. Okay? But it's not really. Yeah, I can tell you. See, I go to Whole Foods about a month ago. You didn't have to wait a lot outside, but lately it's 10 minutes, 20 minutes wait minimum. You just stand there and wait. Okay, hopefully people will get out and then you can go in. And then it is the same thing for every single store. You wait out. Yeah, 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 yeah. Yes. Yeah, I know. I I I also go through the routine routes. I can see that it's more traffic now. It's so obvious. You can see that every time you go to a traffic light, you need to wait up 2 or 3 times before you can go through because people are going there. And then you see more motorcycles on the street. Yeah, yeah, so many. Yeah. No, no. Again, the rule is very clear. If you are around somebody with close proximity, wear your mask. If you are in the woods, who cares? If you go to a wood and you're only a person in the woods, do you need to wear a mask? Nobody would do that. I wouldn't do it. No, sometimes I do it. You know what? It's just I get lazy, taking it on and put it on and off. You know what? It's just put it on. I go to store, and then it's like 2 minutes. You know what? That's it doesn't worth my time to put it on and off. Just keep it on all the time. But may yeah, the right thing you do is you wear your mask. You don't need to wear gloves. But when you get home or go to the store, wash your hands first. When you finish, you wash your hand again. When you go home, you wash your cell phone. Don't put it in water, okay? Just clean it. Don't put it in water, please. I heard somebody put it in water. He said, "Oh, it's water resistant. I can wash it." No, it's not. Okay, it is not. It means that you spill water on the screen, it will sustain. You don't damage. But you put it in the water, they will be damaging. Okay. Yeah, and then that will be fine. And then take a shower, clean everything. You know, it'll be fine. Yeah. So May 8th, this Thursday, which is hopefully everything will be fine, and then we'll be back to a normal life. And wait for the announcement from university because they are going to make announcements probably later May to figure out what's going to happen in the summer. If there's any summer class you can take or anything special, and then in the summer they'll make an announcement for the fall. Yeah, no problem. And for those who are not done, this is not the last term. Okay, hopefully in the fall we'll see each other face to face. Yes, but prepare to wear masks. Go to a classroom. Yeah, me, I'm gonna wear a mask. Okay, and then I'm going to enforce the social distancing. Our classroom is big, so we can sit 6 feet, no problem. And then we'll have small class. Maybe 12 of you will be there, and we can do it. Yeah, everyone is a corner. That's right. Yeah, yeah. We'll be. Yeah, we'll still do the YouTube. Just get the recording done, so in case you need to watch, and then you can still watch it. It doesn't cost me anything. You just bring the computer, set up the hardware and software, and run it. But one thing I want to emphasize again: make sure that you have VGA access. Do not rely on the lab monitor. Okay? So I'm right now. I'm looking at um, how we can connect the what do you call the D10 to HDMI, but there's no solution yet. If that's done, that'll be much better because you guys all have TVs. I know that. Okay, right? You guys all have TVs. You guys all have the HDMI on the TV. So if I can figure out how to do it, that'll be great. But if it doesn't work, make sure that you have the access to VGA. That's a must. Okay? There's no board that's on the market right now that has the VGA built in. None. Okay, I shouldn't say that. I should say none has a reasonably priced. Okay, if you spend 1,000, you can get a very good one with HDMI, but we're not going to get 1,000 one. Okay, we can afford 100. You can buy 100 of them, but we cannot afford 1,000 to buy 100 of them. It's just too much money. All right. Any question about D7? Okay, that's great. So this is what everything I want to cover today. So after class, I'll post the video, the template. Everything else is on you know already the diagrams. So I'm going to correct the typo in the diagram, and then you can continue to work on it. Again, do attempt to finish everything one day. You do the typing one day. You do more typing on the second day. 2 days, you should be able to finish all the typing. Then you start doing debugging. That will take you one more day at most. Okay? Never attempt to do everything in one day for engineering jobs. It's very unlikely unless it's so simple you can just spend like 10 minutes and finish it. Usually it's days of work. Okay? Right? Yes, go ahead. Uh, but I already give you extension. It was the end of it was the end of week 8, so I extended it to the weekend so that you can get it done by Tuesday, week number 9. I don't think I want to extend it again because it will affect your D7. They weigh the same, so if you finish 7, you can recover the credits. Okay? Then you get points for the source code. You get points for demo. Even if you don't have a demo, you need to submit whatever you have accomplished. Okay? I'm very okay with all right. If you submit your code, I give you credit for your code, but the demo it's a separate thing, and they weigh the same. It's like 50-50. Yeah, and this is your last assignment. Let's just finish it and let's finish the term. Don't need to extend this too long. Okay, there's no need to do that. Okay, yeah, you are already in this situation where you need to stay home. You work on this stuff. Okay, it's very different. It's difficult. We're in week 9. Let's just finish this D7 and that's it. Okay. Initially, this class there were project 1 and project 2. I've already waived those, so you don't need to do those. Otherwise, you go crazy. Okay. So right now, if you go to the ULR upload, the last assignment is the demo for D7. And this was for D7. That's it. And then we'll do the final online, do the final exam day, just like this format for the midterm. I'll post questions, then you upload them. Okay? No, D7 is not due today. D7 is due Thursday, May 14th. Today is May 5th. So we'll talk about 9 days. Yes. Last day of class is May 14th. No, D6 was due today. It was due last Thursday, but I give you extension to make it due today. Okay, and then D7, I give you more time to finish it. Okay. So pretty much what I did was I waived project 1 and project 2, and I use those time so they can get more time for D6 and D7. Yeah, that's fine. It's okay. Missing one assignment is not gonna hurt you. If you miss all assignments, it will hurt you. So D7 is the last assignment. So D7 is the last assignment. All right. Anything else? All right. And if you have questions about